All right, welcome everyone. Thank you so much for joining today for ICF Development and History. My name is Bo. I'm with Acelab. We're helping out hosting today's event. I'm just going to give a few minutes of a quick intro about Acelab while folks are joining, and then we'll go ahead and get started with today's presentation. All right, so as I mentioned, I'm with Acelab. We provide free non-sponsored product research for architects. So here is a quick snapshot of our team. We are started by architects for architects, really with the belief that we should be spending more time designing and less time trying to track down the right product information. So we have a lot of search tools and research tools, which I won't go over in full today, but just wanted to give you a snapshot of some of our experts and let you know that Acelab is currently hosting a program where you can actually work directly with our team of experts. It's completely free. It's called our Product Concierge program. And it's our way to just kind of give some more hands-on support. So for folks who are interested in learning more about the platform or just interested in getting expert advice on specifications in your project, I'll launch a poll in a moment. You can let us know if you're interested in that. But overall, this are some of the kind of workflows that we were working to solve. So just the ability to track down information, get in touch with the right product reps, as well as, be able to access educational resources like the webinar that we're in today. So with that, I'm just going to jump us over to our live site and let you know how to get in touch with today's course presenter right directly on Acelab. So everyone who registered for today's event had an Acelab account automatically made for them. It's completely free. So you can jump in and check it out at any time. And if you know the manufacturer you're looking for, you can use this search bar right at the top. So I'm going to go ahead and type in Celblox. So they're the manufacturer helping out with today's webinar. Head over to their page. And right here, you've got a direct button to get in touch with today's presenter, Robert. So if you have any follow-up questions after today's event, this is a great place to come and get in touch with Celblox, as well as explore some more information about their products, be able to check out the product details that they have. So this is a great resource to be able to come back to. All right, with that, I'm going to go ahead and pause my beginning of the intro. We can go ahead and get started with today's educational content, and just wanted to give a reminder to everyone to please submit questions to the Q&A throughout today's webinar. We'll have a record of any questions that are asked so that if we don't get to them, we can follow up with you after today's event. And I just launched our little poll. If you're interested in learning some more about Acelab, feel free to fill that out and we'll follow up with you after today's webinar as well. All right, so without further ado, I would love to pass it off to Robert. Thank you so much for joining today. And feel free to take it away with today's presentation on ICF.
All right, great. Thanks for the intro, Bo. I'm going to turn my share screen on. So, hi, everybody. My name is Robert Viets. I'm the managing director here at Celblox, Insulating Concrete Forms. We're a manufacturer based in Wisconsin. We make all our products right here in Wisconsin from scratch. But I'm not just a salesman trying to sell ICF. I was a licensed general contractor in multiple states for more than a decade now, focused on climate resilient, sustainable structures. Built houses, schools, hospitals, hotels. So I'm not just trying to be a salesman and trying to sell ICF. I really do think it's the best way to build climate resilient, sustainable structures, and I've done a lot of work with it. So I'll get started here. So a little bit on ICF development and history. I wanted to touch base a little bit on concrete first, though, which is one of the main ingredients in building with ICF, because concrete has been getting a bad rap lately within the green building community, which I feel is completely unjustified. One of the negative points that's brought up with concrete is that it does take a great deal of energy to produce the cementitious materials, the cracked limestone, which is the main ingredient in concrete, and it does release a lot of CO2 during that manufacturing process. But limestone being one of the main ingredients of concrete means that concrete absorbs and traps CO2 permanently captures CO2 directly out of the air for the entire life of the concrete. And so after about 50 to 60 years after you pour your concrete wall, after about 50, 60 years of life, it will have reabsorbed all the concrete, all the carbon that was created during its manufacturing process. And then after about 50 or 60 years, the concrete is now carbon negative because it will continue absorbing carbon for the rest of its life and permanently sequestering it. So concrete is actually, if it's for long-term structures, concrete is actually one of the greenest building materials there is. And then at the end of its life, concrete is easily recyclable. It can be ground up and turned into aggregate for new concrete, or aggregate for road bases, or broken into big chunks and used for retaining walls or seabeds, and then where it will continue to absorb carbon out of the atmosphere forever, basically. Which compared to wood frame structures, like wood is great when it's still a tree. It's when it's a tree, it's one of the best carbon sequestering systems out there. But then as soon as you cut the tree down and turn it into lumber, that lumber then slowly releases all the carbon back into the atmosphere for the life of the building, making concrete a much greener choice in the long run. And also when it comes to being resistant to climate disasters such as fire and hurricanes, the concrete structures have a much longer lifetime, service lifetime, which also greatly reduces their long-term carbon footprint. Then the second biggest ingredient in an ICF block is the expanded polystyrene, which also kind of gets a little bit of a bad rap nowadays. But styrenes are a byproduct of the oil and gas refining business. And so when the refineries are making all the different fuels, the styrenes are a byproduct. And so if we didn't use them for something, the oil companies would just burn them or dump them. So since styrenes are a hydrocarbon, the very best thing you could do with them is to permanently sequester them and keep them out of the environment. And so you should definitely, so they're very bad for the landfill. Like, you don't want to make disposable things like cups and coolers and throw them into the landfill. The very best thing you could do with these leftover styrenes is to permanently sequester them into your building projects. And this is actually why, if you build with ICF, one of the reasons that you qualify for carbon capture credits is because of this permanent sequestration of hydrocarbons by using the styrenes in permanent building projects. Not only that, is the energy efficiency of the ICF building over the long term also reduces your carbon footprint versus stick frame buildings or steel buildings. It also leads to healthier environments inside the building because the polystyrene is completely inorganic. It's completely mold and mildew proof. It has no off gassing, harbors no moisture or insects, and which is one of the reasons it's become popular in our hospital projects, because it greatly increases the indoor air quality. And so so those are the two main ingredients of an ICF wall. You can see in the picture here. This is what it looks like as we're building it. So the ICF blocks themselves are kind of like a big Lego block. You stack them up together, form up your whole wall structure, form out your building. Then when you have everything in the shape of the building that you want, then you fill it up with concrete from the top, and then the ICF blocks stay on, though. You don't break. They become your permanent insulation after the pour. So they start off as your form, and then they become your permanent insulation after you're done pouring. Another cool thing is that the blocks have studs embedded inside the foam, so you don't have to do any further furring or anything like that. After you're done pouring your concrete, your drywall can screw directly to the blocks on the inside. And on the outside, you can nail gun your siding directly to the blocks. You can apply your stucco or EIFS directly to the blocks. You can attach thin set masonry directly to the blocks. No furring, no house wraps, no other steps. which saves your time and labor on your construction projects. A little bit of history on ICF. So the first ICF was actually developed by the U.S. military in the 40s, but it was using cement bonded wood fibers, which didn't really work out that well because introducing organics into your building materials usually is not the not the way to go. So the first like modern type of ICF block was patented in 1968 by a Canadian company. And nowadays, ICF is actually the fastest growing segment of the U.S. Construction industry. Last year, ICF sales in the U.S. was about $840 million in ICF blocks, and it's projected to grow at about 6 to 8% a year for the next decade. So there's a lot of business opportunities and growth opportunities in that market space. These are what those first Canadian EPS blocks I was telling you about. That's what these look like. They also weren't that great. They created like a post and beam type, like waffle type system. It led to a lot of bendy walls, a lot of unstraight buildings and unsquare buildings and bendy walls. They weren't that great. They also had no attachment points. So you could not screw drywall to these. You could not attach siding to them. They had to be completely furred out on the inside and outside. So it didn't save any time or money on your construction costs. And so these fell out of favor pretty quickly after the new times. These are what modern ICF blocks look like. These are the kind we manufacture. We make them in different core thicknesses. So this is a 4-inch core, but we make all various core thicknesses for 4-inch, 6-inch, 8-inch, 10 and 12-inch. We make all different shapes, 45-degree corner blocks, radius blocks, brick ledge bearing blocks, taper top blocks, whatever you need for your construction project. Like I was saying, ours have embedded studs every 8 inches. So you have a stud to attach to inside the block. Every 8 inches, you can attach directly to the block. Drywall, but also cabinets, things like that can be attached just directly to the block. No furring whatsoever. We have a patent on these tri-folding hinges. If you can see those in the center, we have that's kind of what differentiates our block, is because our blocks fold flat for shipping. And so we can fit about 3 times as many blocks in a shipping container or a truck as our competitors. And that kind of what sets us apart in the marketplace. Now let's go on to the benefits of ICF construction. One of the big benefits is quick construction. So our blocks are pretty standard at being 16 inches tall and 48 inches wide, which is a surface area of 5.33 square feet. That's about the same as 6 standard size cinder blocks, CMU blocks, but our block only weighs 6 pounds. And so one person can stack basically 6 cinder blocks worth of wall volume, like way faster. So it can greatly reduce your labor costs on a building project, which nowadays those labor costs are, a big part of your construction costs. So another thing we pride ourselves in is minimal waste. So there is some waste on your construction sites because of cutting around your door frames and windows and things like that. Average waste is about 2 to 5%. But one of the cool things is waste pieces can be recut and reused in other parts of the wall to fill other parts of the wall, to try to minimize your waste on job sites as much as possible. And then if you want to go for a truly zero waste job site, you can collect all your cut pieces and we will take them all back, and we'll recycle them all back into new blocks. And then if you want to, so that way your job sites can be truly zero waste if you're going for that. So another big benefit of building with ICF is they are, like I said earlier, they're completely non-organic, and they're closed cell EPS foam. So they're completely water proof. They don't absorb any air or any water whatsoever. They're completely mold and mildew proof. They do not off gas. So your indoor air quality is much higher compared to like a wood frame structure. In a wood frame wall, the moisture penetration through like the electrical boxes, can absorb quite a bit of water. And then another thing that keeps water from accumulating in the walls is because of the thermal mass of the wall. There's almost no temperature fluctuations within the wall, so then you have there's no condensation within the wall whatsoever either, which also reduces any mold or mildew or water collection. How I mentioned thermal mass in the other slide just a second ago, that is actually one of the best features of an ICF wall is its thermal mass. And that is why an ICF wall will thermally outperform any other type of wall, no matter what the other wall's R value is. The thermal performance of the ICF wall will still be higher than the other wall because of the thermal mass, for two reasons. It's the thermal mass of the concrete, and then also the lack of thermal bridging between the inside and outside. So what I mean by that is the concrete on the inside of the wall here is only interacting with the thermal mass of the earth down below the ground, where the temperature is constant. And so the thermal mass of the concrete is drawing that temperature of the earth up through the wall. And then there's no thermal bridging between the inside and the outside. So it doesn't matter if it's 100 degrees outside or negative 30 degrees outside. It doesn't matter. The internal temperature of the wall will be almost constant year round, no matter what. And so the thermal performance of an ICF structure outclasses even other walls that even have higher R values. So yeah, because the EPS foam on the ICF wall, when the block is just empty, is technically an R24. But the ICF structure itself, once that thermal mass of the concrete is added and is interacting with the earth, the ICF structure will outperform even an R60 building, consistently outperform an R60 building for those reasons. We've noted, and then so I got some pictures here. So these are pictures that we took with a thermal camera. This is here in Wisconsin. When it was 3 degrees, we took these pictures when it was 3 degrees outside. We have good building codes in Wisconsin. So this stick frame house is a well-constructed house. We have pretty high requirements here in Wisconsin because of our weather on building codes. And you can still see though, because of the thermal bridging, even this well-insulated stick frame house is still bleeding energy to the outside. And even though this ICF house technically has a lower R value, technically, it's still far outperforming the wood frame house because of the thermal mass of the concrete interacting with the earth, and then the lack of thermal bridging between the inside and outside. And so you can see with the thermal camera, you can see the huge difference. And we notice most people have an energy savings of over 50% compared to a wood frame house. Also, another benefit of that lack of bridging between the inside and outside is ICF is an excellent sound transmission barrier. We've built hotels we built the Hampton Inn in Elmira, New York, hospitals, schools, hotel, and the hotel people really like it because of the extreme noise reduction. You're looking at it like an 89 point decibel reduction between the inside and outside because of that lack of bridging and then the mass of the concrete. So it's great for any projects that you have near freeways or airports, or we've also done movie theaters. We did an IMAX movie theater for the same thing. Also partition walls between multifamily units. It's a great way to keep the sound from passing between units. So our code approvals were we're approved in all 50 states. We are we use Intertech. Most of you guys have probably heard of them. We comply with IRC, IBC. Yeah, we do all the ASTM fire testing. So it's another cool thing about building with ICF is we are rated for 4 hours of direct contact flame. So you can use it for your partition, any fire rated walls you need for your partition walls or anything like that. We easily qualify for those. Our blocks are completely non-combustible. So even if you put a blowtorch right on the block, it will not burn. The foam might melt, but it will absolutely not burn. It will not hold the flame. And then behind the foam is concrete. And so, in areas for like California and things like that, it's also great for places like that. We're also Miami-Dade certified as a Category 5 hurricanes. This is a house of ours here in Wisconsin where the neighborhood took a direct hit from a F3 tornado. You can see it wiped out the whole neighborhood except for the ICF house. So we're ready to withstand Category 5 hurricanes, F3 tornadoes, earthquakes up to 8.0. Direct contact with fire for 4 hours. So it's one of the most climate resilient ways to build structures. And so a lot of you guys might be looking for your lead, your lead points when you're building. So ICF is another great way for building if you're looking to attain your lead points. So we can, with ICF, we can help you get points in 5 out of the 8 categories. Specifically, location and transportation, which assesses a project's location and the carbon impact of transporting goods to your job site. Because ICF manufacturing plants are located everywhere around the country, in regions all around the country. We can directly ship product directly from a factory to your job site. So you'll get points for that. You get points for the energy and atmosphere, which focuses on energy reduction. Because of the energy reduction of an ICF structure, you'll get points for that. And the materials and resources. So that's another one. The materials and resources category promotes waste reduction. So like I was saying in the earlier slide, we can guarantee that you have a zero waste construction site with ours. Materials and resources also emphasizes the life cycles and impacts of materials. And so an ICF house has an expected life cycle that's about 4 times longer than a wood framed house. So you get points for that as well. And then also all the materials of an ICF house are recyclable at the end of its life cycle, which you also get points for. You also get points for the indoor environmental quality. Because ICF has no off-gassing, no VOCs, no mold and no mildew, you get points for that. You also get points for the thermal comfort and acoustic performance. So you get lead points for that as well. You also get innovation points. And so if you're going for like a lead platinum rating, ICF is one of the best ways to go to obtain that. Now I'll touch base in the actual construction methods used with ICF. Like I was saying, I was a general contractor for more than a decade now building with ICF. So this is what I used to spend most of my time doing. So you're going to start with, on your project, you're going to start with footings, just like you would with any other project. one thing about ICF buildings is you definitely are going to want to do a better job with your footings than you normally would. You see a lot of contractors getting sloppy with the footings because they think they don't matter. On an ICF job, it's going to save you a lot of time and money if your footings are finished better and level. If your footings are perfectly level and finished smooth, it will save you a lot of time and money on an ICF project because you don't have to shim and level the walls, which will save you a lot more. It's easier to spend a little bit of time on the footings in the beginning than it is to try to fix the walls as you go up. So that is one thing you have to focus on, is spending a little bit more time on your footings. Another thing is you have to make your footings a little bit wider than you normally would. So there is a little bit of added cost there. Because the ICF wall is wider, you're going to need to add an extra width to your footings. So this is like in this picture, this is an 8-inch core, what we call an 8-inch core. So it'll be 8-inch thick concrete. The footing on this one was 22 inches wide. So that's something to consider. You do need to go a little bit wider on your footings. Vertical rebar is the same as any other concrete wall. You know, you're going to want that pre-implanted in your footing. You're going to follow the same exact building codes as you would with any other concrete wall. As you start constructing up, you're going to be stacking the wall up, and then the windows will be your window and door openings. There's several different ways to handle those. One of the ways is pre-made vinyl bucking. So you can order these from companies such as Gorilla Bucks, Fast Bucks. They're a fast way to do it because they come pre-constructed. You just stack them up in the blocks as you're stacking the blocks, which makes things easy. They're lightweight, they're mold proof, so they will not rot. They don't change shape over time. They're less expensive than steel bucks. They don't warp or twist or crack. They're a pretty good way to go. They're probably my second favorite. The one negative thing about them that I don't like is the attachment points. I'll go on my next slide. So my favorite bucks to use is actually wood bucks. We like to make our own wood bucks. Couple different reasons. Wood is readily available. The attachment points are better all the way around. So on the interior, so where you're doing your drywall returns, or if you're putting in nice wood sills on the inside of your windows, on the outside where you're attaching trim or siding, it's just easy attachment all the way around with not having to worry about what you're screwing in. Like on the vinyl bucks, you have to worry about where you're screwing into because you might crack the buck or break the buck by screwing into the wrong place, or it just might not be able to hold it. So I like to go with wood. Another big reason I like wood is customers change their mind a lot. And so if a customer changes his mind about a door or window size, if you're using wood bucks, you can just change it right there in the field. Doesn't cost much. Doesn't cost much. You can just change it. Whereas with the vinyl bucks or metal bucks, that could delay your whole project now while you order new bucks from the factory. So I like to go with wood. One trick I like to do with the wood bucks is I like to add this piece of extruded foam as a backing. That way the concrete doesn't make contact with the wood anywhere. That way it also reduces any thermal bridging. That way there's no thermal bridging between the concrete and your windows and doors, which just this little step right here can greatly increase your building's efficiency. So I always like to do that. In commercial buildings, like when we do hotels and schools and stuff, they usually go with metal bucks. Like I said, these are usually for commercial buildings. When a customer's not going to change their mind about the shape or the size. They're good for long-term, they're good for long-term maintenance use, like because you don't have to worry about them rotting away or anything like that. they're also designed in a specific way to eliminate thermal breaks. They have a thing here that eliminates thermal breaks, which is nice. They're also fire rated, so that's another pro. The big one for commercial jobs is that they're also fire rated. Other than that, though, I'd kind of stay away from the metal ones. So this is the temporary wall bracing, what that kind of looks like. So when you're this is before you pour the concrete to make sure the wall stays square and level when you're pouring the concrete. It also gives the guys a place to walk up here. This gives you a catwalk up here as they're pumping the concrete, gives you a place to walk, look down into the wall. This is all temporary. It's just screwed. It's screwed directly to the ICF blocks. So like I was saying earlier, where the ICF blocks have embedded studs, these are just screwed right to those studs. These are called strongbacks, screwed directly to the stud, and then the turnbuckle here is used to push that strongback in and out to adjust the wall perfectly square. These only need to stay on until you pour the concrete. They can be removed right after. They go up to 24 feet high. So this is how high you can go in one pour. Maximum pour height is 24 feet. They should be spaced probably about every 4 to 5 feet between them is normal spacing. Rebar reinforcement. Rebar is up to your local code or structural engineer. It's usually the exact same as a typical concrete wall. So whatever your local code requires for a typical concrete wall in your area is the exact same amount of rebar you'd use in an ICF wall. So it's pretty easy to figure out. To place the concrete, we recommend using a boom pump. It's the easiest way to do it. Concrete at a 5.5 to 6.5 slump recommended, and then you vibrate it for consolidation, just like you would with any other concrete wall. The only difference is you don't fill up the entire wall at once. We'd start in one corner, and then we'd pour about a 4-foot lift, and then work our way around the building. Yeah, and work way around the exterior of the building in a pattern, in a 4-foot lift, and then by the time you've made it back to your starting point, then you'd fill another 4-foot lift to the top of the building and work your way around again. Just because you don't want to risk a blowout. So that's the only difference between pouring an ICF wall and the standard concrete wall is you just doing the slower lifts like that. One cooler thing though about an ICF wall though is you can use lower strength concretes because of the insulation of the ICF wall containing the moisture of the concrete. The concrete actually cures slower than an open air cure. So the concrete, since it cures slower, it actually cures to a stronger PSI rating than normal. So if you're a structural engineer says so, you can actually get away with purchasing less expensive concrete mixes or slag concrete mixes. And on to flooring systems. So this is an ICF flooring system that can be integrated directly with the walls. It's the same thing, whereas it's a formed expanded polystyrene, same as the walls, but preformed into an I-beam and a slab. This can be directly integrated into the wall. And so as soon as you're done pouring the wall, you can then just start pouring the floor on top. And we have a lot of customers who do this with things such as garages, where they have like a like they have a walkout basement, and the living room can be below the garage, and the garage is suspended on an insulated flooring system above the living room and things like that. Also safe rooms, storm shelters. There's other various uses, but we've been seeing a lot more of this lately. A lot more customers going this route lately, so it's becoming pretty popular. Some customers now are also using this for their roofing systems, because if you want a house that is like completely tornado proof or completely fireproof, this is a good way to turn your whole house into like a bunker basically. So we're seeing a lot more of this. And it basically has all the same benefits as an ICF wall. The extremely high thermal performance. Not quite as good as a wall because one side of the concrete is exposed. So you don't have all the thermal performance of an ICF wall, but it still performs great. So another thing so these are intermediate floor systems. These are where you'd see these on commercial projects, more so on commercial projects. Hollow core precast. We do see a lot of that on our commercial projects. We just did a hotel down in Belize, and it's all hollow core like this. Hollow core, one of the benefits of hollow core is it's fast. It's faster to do because you don't have to set up the ICF forms and pour them and wait for them to dry and brace them underneath or do any of that. You can just set them in place and you're ready to rock and roll. So it's faster. It's not as well insulated though, so the thermal performance isn't as good. But it is faster. And so for commercial projects, we see that a lot more. Steel truss, we see these on commercial projects for like roofing and things like that, but it also directly integrates with the ICF wall. That's then on residential projects, we do a lot of the wood, still do a lot of wood floor systems in residential projects. We do a lot of open web span trusses, sitting because we have special implanted truss hangers that are like a metal cradle that can be stabbed directly into the ICF wall, and then your trusses can rest right in that cradle, and so you can still pour your exterior envelope all at once, like 2 stories high, and then have your implanted truss cradles, and then just drop your trusses right into the interior, and speed your project up, just be rocking and rolling as you're moving forward. For roof connections, if you're doing standard wood roofs, it's pretty easy. You would just do a sill plate like you would on any other normal concrete wall. Is with bolts, and then your engineered trusses would attach directly to the sill plate, just like normal. In some other areas like Florida and things like that, we do implanted hurricane hangers to set your trusses in. That just depends on your region though. Things like metal roofs, things like that, you can do direct implant beam pockets pretty easily. If you need to do pilasters, you can integrate pilasters directly into the wall just by cutting some ICF blocks. Then you can pour your pilasters and your walls all at the same time. So for one of our most common questions is how do you do the electrical and plumbing into the ICF? It's actually super easy. You do not have to put conduit into the concrete at all. So after you pour the concrete, you come back with a hot knife or a roto tool or a chainsaw, and you cut channels just in the foam, and you implant your electrical and plumbing into the foam. And so you don't have to do anything into the concrete. You just go into the foam. And then you would just use a can of spray foam and spray foam this shut after it's installed. This picture shows the wiring and conduit. You would do this on the exterior, but on the interior, code allows you to just use normal Romax wiring. You do not have to use conduit on the interior walls. Because the foam is 2.5 inches thick, as long as you implant the wiring at the very back of the foam, where it has to be deeper than a drywall screw will go. But as long as you're deeper than that, you do not have to use conduit. You can just use standard Romax as per code. And so it actually can be easier to install electrical in an ICF wall than in a stud frame wall, because you don't have to drill through any studs or do any of that. The hot knife cuts through it like butter, and you put your wiring in your boxes in, and then you spray foam it shut. For finishes, like I was saying earlier, there's unlimited finishing options. Because of the embedded studs, you can attach directly to the blocks, no furring, no house wraps, none of that. You can nail gun your siding directly to the blocks. You can apply synthetic stucco or EIFS directly to the blocks. Thin set stones can be attached directly to the blocks. If you want to use a heavier stone, we make a block with a brick ledge that sticks out to support the weight of your stone, and so you can attach that directly to the block, and so you can save time and money on your exterior finishes. As synthetic stucco is a good some of our projects now, like the hotel we just did in Belize and the school we did in Kentucky, actually used thin set synthetic stucco for their interior finish as well. Instead of doing drywall, they did just thin set synthetic stucco, super smooth finish, but they did that for the inside and the outside. And that saved them a lot of time and money too on their finishing. Typical interior finishing though is still gypsum board, which is screwed directly to the blocks. That's still what we're seeing typically. Like I was saying, we're seeing some customers switching to the synthetic stucco for the interior finish as well because of the cost and time savings. Also, the synthetic stucco is pretty cool stuff. Like it's also fireproof. It's completely hydrophobic. It's mold and mildew proof, and it also adds R value to the wall. So it's less expensive than gypsum board. So we're seeing a lot of our newer customers are starting to switch to that. For design and applications, condominiums, as you can see on this project, it wasn't just the exterior envelope. It's also all the interior, the interior partition, not all the interior partition walls, but the separator walls between units, because of our 4-hour fire rating and almost complete sound deadening. It's easier just to use them for the interior, the partition walls between units as well. They're also load bearing, so that can save time and money on your construction projects. Theaters. This is an IMAX theater we did. They did it to reduce sound transmission between the units and between the outside. Hotels. We've done multiple hotels. This is a sleep in, but we've also done some New Hampton Inn hotels. And they did the same thing as the condominiums, where they also did the interior partition walls between the units out of ICF for the sound and for the fire code. Assisted living facilities. We just did a 300 room assisted living facility here in Wisconsin, Sauk County Health Center. Basically all the same reasons as the other ones, but it's sound and fire ratings of the interior partitions, so they just did the inside too. Schools, we did Bowling Green High School in Kentucky, Flowerty Middle School in Kentucky. On those ones, we got those jobs because of the energy savings. Actually, on Bowling Green High School, we saved them over $3 million by switching to ICF, because they were able to reduce their solar panels and their heating and cooling, the size of their solar panels and the size of their heating and cooling systems, because of the increased efficiency of the ICF walls. And so even though they spent a little bit more money on the ICF, the overall cost of their project came down by $3 million. Churches, yeah, we did done several churches now. Yeah, for them, energy savings is the big one. It's a big building to heat and cool. Shopping malls, same thing with that. Like the bigger your building is, the bigger the energy savings. So it works good for those. Medical facilities. Detailing, wall detailing. That's one thing people ask us about a lot. So you can see this curved turret. That's all ICF. That curve, that is a radius wall made out of ICF. It's no problem at all. This big radius down here, that's all ICF. We can make those. It's no problem at all. So in any kind of design concept you can come up with, we can, ICF can facilitate. Same thing with like spans and window and door openings. Steel reinforced concrete is 10 times stronger than wood. So any kind of span or opening, anything like that you can think of, we can accommodate. Arched windows are easy to do because all you have to do is cut the foam block. You would simply cut the foam block in the shape you want, and put your window buck in, and it's no problem. Gables. So we even do gables up to the tip top. That's all ICF. Same thing. Blocks are just put in place and then cut into form. With this, you can cut them with a skill saw, table saw, sawzall. They can be easily cut into any shape you want and then poured. So we can accommodate any kind of design considerations that your projects might have. Porches and floors. So these porches are the ICF flooring system that I showed you in some of the earlier slides, on top of an ICF wall. So it can bear just about anything that you can think of. We can board. Production housing. So we also do low income housing. It's a pretty good way to. So we're doing like a lot of the new Habitat for Humanity homes are being built out of ICF now, because of the energy savings of the home, the climate disaster resilience of the home. There's also more savings is if your home is built out of ICF, you get about half off on your homeowner's insurance. It's called the future-proof resilient building discount. You also get a better interest rate on your mortgage if you built out of ICF. Part of the new infrastructure bill is they're called EEMs, energy efficient mortgages, or green building mortgages. So you get a better interest rate on your mortgage if you build out of ICF now. And so for affordable housing, it's becoming the way to go for affordable housing as well. Last year here in Wisconsin, Habitat for Humanity did something like 150 ICF houses just here in Wisconsin. And so then these houses in this picture, this is the Habitat for Humanity houses in Texas. And so Habitat for Humanity has really stepped up into the ICF world. Just getting into some special applications. This was I believe this was Flowerty Middle School, but this is the gymnasium at Flowerty Middle School. They had to use the red steel to get the extra long spans for the gymnasium, and so they just used this ICF to infill between the walls. As you can see, since the blocks are easily cut, you just cut the blocks around the red steel, and then you can just infill wherever you need. You can see here more radius walls, can be easily radius walls, no problem. Retaining walls or just garden walls. You see this is the garden wall finished with synthetic stucco and thin set stone attached to the ICF. We're also doing swimming pools now. Swimming pools are becoming popular to do with ICF because if you want to do a heated swimming pool, the ICF actually saves you a bunch of money on that because the water is no longer in contact with the concrete, which is no longer in contact with the ground. And so the same thing I was discussing earlier, the lack of thermal bridging saves you a bunch of money if you want to have a heated swimming pool. And then firewalls, you just see here the firewall they're doing the interiors. The interior partition walls are still wood, but they did the firewall between units out of ICF because of the 4-hour fire rating and the sound transmission. And yeah, that's about it. And so I'd be happy I could talk about ICF all day. So if anybody has any questions, I'd be happy to discuss them with you.
Awesome. It looks like we do have quite a few questions. So if it sounds good, I'll just start reading them from the top and we can see how many we can work through.
Yeah, absolutely.
All right, cool. So first one, when you break down concrete for reuse, does it still retain its carbon or does it release carbon in that process?
No, it retains the carbon forever. When you break it down for reuse, it actually absorbs even more carbon from the air because the surface area of the concrete, when you break it into little chunks, the surface area of the concrete increases. And so it absorbs even more carbon from the air
Hmm,
from that point on, as long as it stays in contact with the air.
right. Cool. All right. This one says, so slide 6 showed a wall that was wavy and not straight. How are the blocks aligned and braced to be straight? What is the allowable tolerance over a given length?
So in that picture, I did notice that was a little wall. So that wasn't my install. So if it was my install, the wall would have been a little bit straighter. But usually the turnbuckles, some contractors don't bother straightening the wall until after they pour the concrete, because you straighten the wall with those the strong backs and the turnbuckles that went down to the ground. After you pour the concrete, you want to do a final squaring of the wall. And so you'd have one person come by with the level and another person turning those turnbuckles to bring the wall perfectly square. I like to start with the wall perfectly square and then re-square it again. But some contractors just don't feel the need, so they just kind of leave it and then square it at the very end.
Right.
I don't want to risk that though, so I like to keep it perfect from the beginning.
Yeah, that makes sense. Okay, is there a locator for the stud on the exterior side of the panels in order to know where to attach it to?
Yes. So our blocks have lines drawn on them. Every 8 inches, there's a line drawn that locates where the center of every stud is every 8 inches. But another benefit of our blocks is our block, the hinges, our folding hinges that I showed we had a patent on, they are pinned with steel pins.
Hmm,
And so the studs in our block can actually be found with a stud finder as well, if they're covered.
cool. Awesome. All right. Next up, can ICF blocks be made custom for custom walls?
Yes, depending on your needs, we can make different shapes and sizes depending on your needs.
Cool. What is the maximum height of an ICF wall?
25 stories.
25 stories. Wow.
Yep. So in downtown Ottawa, there's like over 80 buildings in downtown Ottawa that are 20 stories and up, all ICF.
Wow. Very cool. All right. Does it cost anything if I return cut waste product other than shipping?
No, we'll take them all back for free.
Awesome. Any special requirements or modifications for Florida applications?
So we have the Miami-Dade certification. We're Miami-Dade certified for Category 5 hurricane, high velocity wind zone. So you will have to talk to a structural engineer because they do have requirements for rebar.
Mhm.
That's not up to us though. But our blocks are good to go for Florida.
Awesome. All right. How are lintels over windows handled? And do you have bond beam ICF configurations?
So the lintels over windows and doors are just the standard ICF block. The only thing you would add, it would be up to your structural engineer. But the only thing you would add on a really long opening would just be more rebar into the, because it's still an ICF block at its core is steel reinforced concrete.
Mhm.
And so steel reinforced concrete can span anything that wood can span, steel reinforced concrete can span.
Okay, cool. This next one looks like more of just a comment, but Joel asks, did you take the picture of Mark and Jerry of Devo? Nice. 5 stars for any presentation with a picture of Devo in it.
Mark and
I don't know who Mark and Jerry are, but I guess
I don't know. Yeah, I don't know who Mark and David there. I don't know who that is.
Cool. All right. And then looks like this might be one of our last ones. So we've got a few more minutes. If anyone else has a question, feel free to submit it now. How does the cost of ICF compare to that of light wood frame and to metal frame?
So it depends on the application that you're building for. Because like I was saying, we make the ICF blocks in all kinds of different core sizes. And so also depending on so if you're going to build a finished basement, the ICF block will actually be less expensive because it already has the studs embedded into it. So if you're going to pour your basement, you can then attach drywall to the inside, and now you have a finished basement, in one step. So in that, so it's really hard. It's really hard to say without seeing the specific building plans of what you're planning on doing with it. But the price, it doesn't cost. I would say it doesn't cost extra because it eliminates those steps. Even on above grade building, if you do a lightweight wood structure, you still have to come back, and nowadays, they're putting that zip board on the outside. You have to insulate the inside. You have the vapor barrier or house wraps. You get to eliminate all of that, and then the labor savings.
Right.
So it depends. Yeah, it depends on your specific application, but it doesn't cost extra.
Cool. All right. For custom residential, are builders constructing a second wood framed wall just inside exterior wall as a service chase, or for ultra flat surface for finishes?
No, you can attach your electrical gets channeled into after you pour the concrete. We use a hot knife or a roto tool or a chainsaw, or whatever you want. After the concrete is poured, you can channel into the foam and directly put your Romax directly into the foam, and then seal it. And so you do not need, and the foam has studs inside of it for attachment, so you do not need to put any furring whatsoever on the interior.
Okay, cool. Awesome. All right, looks like we might have gotten through all of them. So I'll do one last call for any questions. But if not, really want to thank everyone in the audience today for asking so many thoughtful questions and for coming out today. I know this end of the year time can always be a little bit hectic, so we really appreciate you taking the time to come and learn about ICFs with us today. I'll leave the poll up for another moment or so. And yeah, Robert, thank you so much. This was incredibly informative and a really great presentation.
All right, great. Thank you for having me.
Cool. All right. Thanks, everyone. I'll go
Bye.
ahead and everyone go a few minutes early. All right.